Well, we have another question here, question 5. The question says, the diagram below shows the graph of g of x given by 2 over x plus p plus q and f of x equal to log of x base 3. Now, we have like y equal to -1, the horizontal asymptote of g. B is 1, 0 is the x-intercept of f. A is the point of intersection between f and g. The vertical asymptotes of g intersect the x-axis at E and the horizontal asymptote at D. And then it is also said that OB is equal to BE. Now, let's start with question number 1. Question 5.1 here says write down the range of G. Now, first of all, what is the range? Okay, the range are just the acceptable y values. Okay, so the values that can be accepted in the equation or the graph of hyperbola. For cases of hyperbola, we know that hyperbola has what we call asymptotes. Okay, so the range asymptotes are all the acceptable y values. So it means all the values of y except the horizontal asymptote. And then we can say that the horizontal asymptote is given by -1. So we can write that the range by, we can write it, I can write the question over here, question 5.1. We're looking for the range of G. So the range of G is just y elements will be, I'll write like this. The range of G will be y is element of R such that y is not equal to -1. Okay, because when y is -1, the asymptotes, I mean, when y is -1, the G of x is not defined. Over here, you can see no, the value of -1 is associated to no x value in the graph of hyperbola. So we can write like this, or sometimes we do write like, you can say the range will be R minus the element -1. It can also be written like that, it's correct. Or sometimes they can write, no, I prefer to give this to. And the other question is question 5.2. The question says, excuse me, determine the equation of G. Now, I'm gonna write the question over here, 5.2. 5.2, we're looking for the equation of G. Okay. In the question here, it is given by G of x is given by 2 over x plus p and then plus q. Now, it is important to note that p and q here are just stand for the asymptotes. Okay, the vertical asymptotes and the horizontal asymptotes respectively. Now we need to find the value of p and q. In the previous question, we didn't notice that the horizontal asymptotes q is just -1. Now, it is important to keep writing your formula for hyperbola like this. Hyperbola is given by a over x minus p plus q. Okay, that's the general form of hyperbola. Now we need to find, we already know the value of q. Here it's -1, the horizontal asymptotes, but now we need to find the value of p. What can we do? Now when we look at the equation here, among the information we have about the graph, it is said that OB is equal to BE. Okay, so now let's see. OB from O to B is 1 unit because the coordinate of B here is 1. So meaning the length OB is 1 unit. And then because OB equal to BE, okay, because these two are equal, consequently, E also is, this is going to be 1 unit. So by here, the X coordinate is 2 units. Now, when you look at D, D is on the same vertical asymptotes, meaning the X coordinate of D is also, the equation of D will be 2, -1. 2, -1. Now we can write over here the vertical asymptote is 2. Okay, so therefore g of x will be 2 over x minus 2. Okay, because minus p is 2, and then plus minus 1 is just minus 1. Okay, minus 1. So that's the coordinates of actually the equation of g of x. Now the following question is question 3. The question says here, calculate the value of t. All right. When you look at t, is a coordinate of the point A, and then the point A itself is an intersection of the hyperbola. Okay, the intersection of hyperbola and the exponential. Okay, this and the log function here. Now, what can we do? Okay, I think I need some space. I'm gonna write here 5 points. 5.3. We're looking for t. Now, the fact that the coordinate of A are like t1, okay, A is t1, that's given. So the t stands for the x intercept, and then 1 the y intercept. So now the equation of f of x is given by log of x base 3. Let's check it again. We can see it over here. F of x is log of x base 3. Now, so it means when x is t, y is 1. Remember, f of x is the same thing as y. So we can just see y equal to log of x base 3. Now we can sub in the values of x and y. So the values will be log base 3, the value x will be t, okay, and then y is 1. Now I can reverse this order. It's like log of t base 3 equal to 1, and then this is possible if t is 3. Okay, if t is 3 here, or according to the log formulas, we can just say t equal to excuse me, this will be t equal to 3 to the power of 1, which means t equal to 3. Okay, t equal to 3, or else we can also use the equation of the hyperbola to find the value of t, because g of x is given now by 2 over x minus 2 plus 1, actually minus 1. We can substitute the value of excuse me, we can substitute the value of because g of x is like y equal to 2 over x minus 2 minus 1. We can substitute the value of y. As the question says that when it's the equation t1, a is t1, so meaning when y is 1, and then x will be equal to t at the point a, so it's going to be 2 over t minus 2 minus 1. Now if I move the negative 1 over, that's going to be 2 equal to 2 over t minus 2. Okay, and then we can cross multiply. So because 2 here has a denominator of 1, so we can multiply by doing 2 here times t minus 2, and then 1 times 2 there. So it's like that. Cross multiply, and then this will be okay, I think I can just turn my page over here. This will be like it's going to be, if you cross multiply, it's going to be 2 times t minus 2 equal to 2 times 1. And then that makes 2t minus 4 equal to 2. And then if I move the negative 4 over, that makes 2t equal to 2 plus 4. And then 2t equal to 6. And then that means t equal to 6 over 2. And that makes t equal to 3. So that's the value of t. And then the following question is question 5.4. Question 5.4 says that write down the equation of f minus 1, the inverse of f, in the form y equal to. All right. You know, because f of x is the equation of a log, you must know that its inverse must be the equation of it's going to be an exponential equation. That's how they work. Okay, the inverse of an exponential equation will be a log functions, and the inverse of logs must be an exponent. Now let's prove it out. I'm gonna write the question here, 5.4. 5.4. We're looking for f minus 1. Okay. Now, when the equation is given by f of x was given by y equal to log of x base 3. Now, how do we work out the inverse? It's when we substitute the value. Okay, we switch the values. We call y x and then x, we call it y. So this is going to be like x equal to log of y base 3. So x equal to log of y base 3. Now, if I reverse that order, it's going to be like log of y base 3 equal to x. Now, applying the log formulas or the log properties, this will become y equal to 3 to the power of x, because it says, the property says like if log of a base b, okay, equal x, this means a equal to b to the power of x. So this is what I apply. Log of y base 3 equal x. It simply means that y will be 3 to the power of x. So that's okay, I can just write it over here. Y will be equal to 3 to the power of x. So we have f minus 1. That f minus 1 of x. Okay, and then we have like the next question must be question 5.5, and then the question says the question says, for which value of x will f minus 1 of x lesser than 3? So for which value of x, okay, will for which value of values of x will f minus 1 lesser than 3? So we can work it out. We can calculate this. That was question 5.5. So 5.5. We're looking for this values of x. Okay, will f of x, f minus 1 of x lesser than 3? Now, we already have written this. X is equal to 3 to the power of x, y equal to 3 to the power of x. This is f minus 1. Now, lesser than 3, it means we can write like or I mean, in another words, it means we have like 3 to the power of x, which was stands for the equation of f minus 1 lesser than 3. Okay. Now, it is important to note that when you see a number like that, it has an exponent, okay, of the power of 1 is there. So now, in this situation, this simply means, according to the law of exponents, when the bases are common, we're going to equate the exponents. But here we don't have an equality, we have an inequality. So we're going to say x is lesser than 1. Okay. I did that in reference of this law, a to the m equal to a to the n. This implies that m equal n. Okay, but now we didn't have an equality, but we have an inequality. So we're just going to say m is lesser than n. So in this case, x is lesser than 1. Now the following question must be question 5.5, 5.6, I mean. And then what the question says, I'll move it like this. The question says, determine the point of intersection of the graph of f and the axis of symmetry of G that has a negative gradient. Okay. Determine the point of intersection of the graph of f. Okay, the graph of f is this one. Okay, and the x and the axis of symmetry of G that has a negative gradient. Well, we need to understand that this has an equation, or maybe I should reproduce the same diagram over here. So we have like a better insight in the equation. Let's just put it, I meant that. Well, now let's first, as I was saying, let's put the diagram over here. So this is the same diagram. Now we want the point of intersection between the graph of f and the axis of symmetry that has a negative gradient. It is important to note that equation of hyperbola, okay, G, the equation of G has 2 lines of symmetry, okay, that passes through the asymptotes. So it passes through the coordinates of the asymptotes. In this case, it's D, because D over here is the point where the 2 asymptotes intersect. Okay, so the line of symmetry will be like the line that passes through. So I pass through D here. So one goes like that. Okay, and the other will be like this one. Okay, approximately that. Those are the line of symmetry, but we want the line of symmetry that has a negative gradient. Okay, in this case, it must be the line that decreases. So not this line, only that one. Okay, and then a formula I can call it like that for the line of symmetry would be okay, you know, the line of symmetry are straight lines, so they are the form y equal to mx plus c. Okay, now with negative gradients, it must be, because the coefficients are either 1 or -1, so this will be y equal to negative x plus c. Okay, for all hyperbola, okay, here for all these hyperbola, the line of symmetry has +1 or -1 gradient. So with the negative gradient, it must be -1. Now it passes through the point D. As I was writing here, D was the point to -1. So we can substitute the points here, -1 and then 2 for x, and this will be equal to minus x plus c. So that makes -1 equal to, if I move the -1 over, it becomes positive. -2 over, it becomes +2 equal to c, and then -1 plus 2 is just +1. So c is 1. Therefore, the equation will be -x plus 1. Okay, this is one way you can solve this question, or an alternative way is to use the formula that I'm going to write over here. You can use this formula, y equal to m open bracket x minus p plus q. Okay, knowing that p and q are the asymptotes of the hyperbola. So now actually I can just make the formula better. Let me write it this way, plus minus. Okay, yes, like that. Now when we talk about a negative gradient, we're going to select the negative. If there's positive gradient, we're going to select the positive sign here. So now negative gradient, therefore, it will be y equal to minus, open bracket, x minus p, which is 2, close bracket, plus minus 1. Now this will make y equal to negative x, okay, plus 2 minus 1, because you know when you drop the brackets, this will make negative x, and then negative here will make plus, and then this will be y will be equal to minus x plus 1. So this is the equation of okay. This is so far the equation of the line of symmetry that has a negative gradient. Now we want the point of intersection. In other words, we're going to equate to see where the two equations meet. Now we're going to set this equation equal to this other equation. So this will be then so okay, now to find the point of intersection that I was saying, we're going to equate the three equations, but now let's see first what's gonna happen. If I do f of x is given by log of x base 3 equal to negative x plus 1. Okay, so in other words, it means x equal to this x here equal to 3 to the power of this, so equal to 3 to the negative x plus 1, or which means x is equal to okay, because this can be split as 3 to the power of negative x times 3 to the power of 1. Okay, law of exponents. Still quite a lot of work, but now let's see. This will make that x equal to 3 times 3 to the power of negative x. Oh, we quite stuck here. What can we do in this situation? No, not really. Okay, maybe this can be written as again x equal to 3 over 3 to the power of x, but it's still not really it's giving us like a lot of work here. But we can bypass this calculation by look at the graph. When we have like the line of symmetry y equal to negative x plus 1, let's try to represent this graph clearly. Okay, I wanna just represent this graph clearly here. If I need to draw the graph, you see that the y-intercept of the graph here is 1. Okay, y-intercept, it means when x is equal to 0. So y-int means x is equal to 0. Or maybe let's just write it over here because of space. Okay, y-int means x equal to 0. So therefore, the value of y will be equal to the y-intercept will be just 1 when you sub in 0 for x over here. So y will be 1. So now when x is 0, y is 1. But now if we look at the points here, it's also when x, okay, the point b is 1, 0. So we're saying 1. Let's also work out the x-intercept, because I just want to try to make to represent the line of symmetry well. So the x-intercept means x-int means when y equal to 0. X-intercept means y equal to 0. Okay, so if we sub in 0 for y, because the equation is y equal to negative x plus 1. If I sub in the value of y is 0. Okay, this will be 0 equal to negative x plus 1. If I move the negative y negative x over, that makes x equal to 1. Now we have the points here, we have the points like 1, 0, and there is the points 0, 1. Now when I look at these points here, 1, 0, this is the same point as the point B. So this is the point B lies on f of x. So the point of intersection is the point 1, 0. And then you can check it out here also. If x is 1, y must be equal to 0. You can check if x is 1, you sub 1 here for x, you have 1. If you sub 1 here, 1 will be equal to 3 over 3 to the power of 1 is just 3. And then 1 is 1, 1 equal to 1. So the point of intersection is the point 1, 0. So this is the point of intersection, 1, 0. Thank you.